All right, so in this class, as I said, we're going to cover the tutorial sheet MAT 101, tutorial sheet 1, and we'll answer the questions that are in this tutorial sheet. Just to get a build up of what we're gonna do here, I'll be explaining most of the concepts as we go on in this class. So there are things maybe you've not done, or things that you've done or not done, but I will presume that you have done most of the basics, and I will be explaining some of them as we go along. So if you have any questions along the way, feel free to ask. Just feel free to ask, and I'll attend to that. So let's start from here. Question 1 says, use a Venn diagram to show that the region. Use a Venn diagram to show the region described by. So we have these here, A, B, C, up to D, and that telling us to use a Venn diagram to show that region that is described by this set notation here. So we have different set notations there, and we have to use the Venn diagram. So the first one we have is P intersect Q complement. We have P intersect Q complement, and they've told us to use a Venn diagram. So my Venn diagram is going to be something like this. So I have this here is what I call my Venn diagram, and this E represents my universal set. It can be written as E or it can be written as U. So whichever you feel like using, or whichever they've used in that context, it will still imply the universal set. Then I have my two sets that sit here. I have like that. So I have set P and set Q. So I have this P intersect Q. P intersect Q. So in this first one, we must understand. So it's P intersect Q complement, in fact. P intersect Q complement. So we strive first to explain what the complement means. So if I have a set Q, so the set Q, let's say I have a set Q, and the set Q has elements 1, 2, and 4. Then I have, let's say, the universal set U, which is going to be given, let's say it's 1, 2, 3, 4, and what, and 5. This here is my universal set. Then I have my set Q. So the complement of the set Q is all elements that are not in this set Q, but they sit in the universal set. So I see that my set Q has 1, 2, and 4. So the elements that are not in this set Q but sit in this universal set are 3 and what, and 5. So meaning my Q complement is going to consist of those elements, that is 3 and 5. So when we are talking of complement, we're talking of elements that are not in that set. Okay, so now from there, now let us try and shed what we've been given there. So from what we have here, they're telling us P intersect Q complement. So always when you see the Q complement, it's very important that you start with the part that has the complement itself. So start with Q complement. What is Q complement? So I will do it in 2 stages. I'll do it in 2 stages such that you're able to see how it comes out to the final answer. So what I'll do is, okay, so we have this, and they're telling us Q complement, meaning we're not gonna shed anything that is in Q, but we will shed everything else that is in the universal set, but not in Q. So that implies this here, the outside, or this here, apart from the set Q. So I'm not gonna shed the set Q because it's Q complement. So this here, so this shaded in white is what is Q complement. So this shaded in white is what is Q complement. Then they say intersect. So there's this intersection sign. Then they say intersect P. So in short, they're saying P intersect Q complement. So now the intersect part where I'm going to come is I have the set P and they're intersecting it with the set P. So what that means is they're They're looking for what is common between the complement of Q and the set P. So now, how do I get that? I'll just shade the set what P. So to get that, I shade the set P. I'll use these lines in this direction like this. Okay, like that. So now, here from when you get to this stage, what you do next is you check which part of this Venn diagram here, where are these two lines crossing? So I have used the white lines and the yellow lines. So you see where those parts are crossing. And where those parts are crossing, that is going to be what? Your P intersect Q complement. So to write that alone, it's going to look something like this. So I'll have there and there, I'll have my P and I have my Q and of course my universal set there. So meaning my complement or this, I mean this P intersect Q complement is gonna be this part here, which is going to be there. So this is how you show, because we see from this other part where they crisscrossed. So this is where you just shade now. So your final answer is gonna be this. So this is how you show that region there. As I said, if there are any questions as we get along, please feel free to ask. Okay, let's move on to part 2. So part 2, let me erase this. So part B is P union Q, then complement. So for me to shade this or to show this on a Venn diagram, I first must show what P union Q is. So the operation, the set operation union just brings all elements together. So let's say I have P and P is equal to 1 and 3, then I have the set Q which is equal to, let's say it's equal to 1, 2, 4, and 5. The union of these two sets is going to just be, so P union Q, the union brings all these elements, combines all these elements together. So that's going to be 1, 2, I have 3, 4, and 5. So that is going to be the union like that. So if I'm to draw the union like this, so I'll have there and there, I'll have P and have Q there, and of course the universal set. So my union is going to be what? All these elements brought together. So meaning P and Q, everything here brought together. This is my P union Q. So the complement of this means it's going to be what? Outside. Anything that is outside this is going to be what? P union Q complement. So anything outside what we've shaded here is going to be P union Q complement. So that is going to look something like this. And I'll have my E there, and I'll have set P and the set Q there. So anything outside that, so here white, anything outside where we didn't shade there, that is going to be my P union Q complement. So that there, here outside. So I'm not going to shade set P and Q, but I'll shade there. As you can see, the remaining part of this universal set there. So this here is going to be my P union Q complement. Okay, so let's move on. Okay, to part C. And okay, so part C. Okay, so with part C, we're just doing kind of a similar thing, but now here we see that there's a third set that is introduced. So a third set that is introduced. So I have a third set introduced, which is R. So if I'm drawing my Venn diagram, I'm having it like this, and there, and I'm gonna have 1, 2, and 3 there. So gonna have P, Q, and R there. So these are the three sets that I'm having. So the first part says P, that's P union Q complement. So P union Q complement. So I'll shade first of all what P union Q complement is. So meaning I'm not going to shade P and Q, but everything outside P and what? P and Q, because it's a complement that's there. So how am I gonna get that? So I'll shade there outside P. So including this part of R here will be shaded, including that part of R there, I'll shade there, like that. Apart from P and what? P and Q. I'll shade everything else apart from P and Q. So this here is P. This is my P union Q complement. Then they're telling me intersection R. So I have to see and check where does this intersect with my what? With my R. So I shade my R. I'll use the lines going this way. I shade my R like that. Then I check now from this entire diagram here, where do these lines crisscross? So they crisscross at this region here, and I can clearly see that when I separate it there, like this, and I'll have, so I have my P, Q, and I have R there. So this is going to be P, Q, and R. Then I have my E there. So the crisscrossed part here, where those lines crisscrossed, is just this region here. So this here is my P union Q complement intersection R. Okay, so now let's move on to the next one. Let's move on to the next one. So for the next question, still similar concepts. So the first part says P intersect Q, then you have intersect R complement. So wherever you see a complement, it's good to always start with the part that has the complement. So I have 1, 2, and 3 there. Then I'm going to say P, Q, and R, then E. So R complement is everything outside what? Outside R. Apart from the set R, so everything outside R is going to be this. So I'll just not shade R, but I'll shade everything else. Okay, there. I'll shade there, but I'm not touching the set R at all because it's a complement. So this here is R complement. So from here, I then have to shade, they're telling me P intersect what? Q. So where is P intersect Q? So P intersect Q is this part here. This is P intersect Q, like this. So now I check where do the white lines cross with the what? With the yellow ones. So where do the white cross with the yellow ones? So that is going to be my what? My final answer. So I'll have 1, 2, and 3. And I have P, Q, R there. Then that is gonna be, so the part that is remaining is gonna be this one here, just there, like that. So not this small section here, but just there we have shaded in blue. So that's our answer for this final one. And this marks the end of the first question. I don't know if I have any question here. Have I left anyone behind? Are we together here? Okay, so we are together. So we move on to the next question. Okay, so the next question, right. So the next question says, list the elements of the following sets. List the elements of the following sets where n is a natural number. So key here, they're telling us n is a what? Is a natural number. So natural numbers are numbers that we use for counting. That's starting from 1 all the way up to infinity. So that is going to be 1 all the way up to what? Infinity. So I can write it like this in interval what? Interval notation. So that's how it's going to be. So now from here, how am I going to get those values that they're asking for? So I know that they are discrete and they're not, these counting numbers are not, they're not decimals. So they're whole numbers, like it's 1, 2, 3. So they're starting from 1 all the way to infinity. So now for the first one, I have my A, And they're telling me, if I read this set period notation, what it says set A is a set of OX such that, so X is valued in between 3 and what? And 12. 3 and 12. But as we can see, there's a less than, and these less than signs have no equal to part. So it's just the less than. It is not this sign. So since it's this one, the first one, which is just less than, it means that implies that 3 and 12 are not part of this set. Then I have that X. So they're telling me that X is a member of natural numbers. So make sure when you're listing, it's a member of natural numbers. So this listing form is called roster form or tabular form. So I'll list, meaning my numbers will not start from 3. It's going to start from 4, then 5, 6, 7, 8, 9, 10. Then I have 11 there. Since 12 is not part of that set because of the sign given there. Okay, so this is how you list down the first one. Then I have B. Okay, I have B, and B says set B is a set of OX such that X is even. So X is an even number, and that even number has to be less than or greater, has to be less than or equal to 20. So they're telling us that X is less than or equal to 20. So now we need to list down the even numbers that are less than 20. And we know that the products that they are what? They are natural numbers. The natural numbers, as we said, there are 4 there. There are 4 in that interval there. So, meaning if we're going to start listing here, we list from, so our first even number is going to go out to be 2. Even numbers are just numbers divisible by what? By 2 and leave no remainder. So I have 2, I have 4, I'm going to have 6, 8, 10, 12, 14, 16, 18, then 20 is going to be the last number. So this here is going to be my set B. Then move on quickly to set C. So set C is given. So it's saying set C is a set of X such that, so it's given by this equation. Then they're telling us X is a member of the natural number. So it's given by an equation. So we can check that equation. So it's 4x, it's 4 plus x, equal to 3. And solving the value of x, I'm just going to get x equal to 3 minus 4. And this is just x going to be equal to -1. So now they're telling me that x has to be a member of the natural numbers. But if I check here, -1, is -1 a natural number? No. So we're seeing that x is not a member of what? Of the natural numbers. Here, x, like -1, not x. So I have to say -1 here. So -1 is not a member of what? Of the natural numbers. So, which means if it's not a member of the natural numbers, meaning this set here, C, has to be what? An empty set. So you can denote an empty set like this, or you can denote it like that. So this is going to be the value for the set C. That's how you're going to list it. It's going to be empty, an empty set. Then they're telling me set D is a set of all x such that x is a multiple of 3. So multiple of 3, these are numbers that I get when I multiply 3 with an integer. 3 with an integer, and that integer, of course, has to be a natural number. So it can be given by the equation. So I can say D, we were obtaining the values of D through the equation 3x, where we're saying x is a member of what? Natural numbers. So meaning starting from 1, if I put 1 here, I'm going to get 3. If I put 2 here, I'm going to get 6. I put 3 here, I'm going to get 9. So the set D is just going to be multiples of 3, that is 3, 6, 9, 12, 15, and it continues all the way up to what? Up to infinity. So they did not give us a limit here, so it goes up to infinity. You can just denote it by those dots there to show that it continues to go. So that is how we solve this question. I don't know if anybody with a question here. Okay, so we move on to the next question. Okay, I have a question. No, there's no question. Okay, checking, is that a question? Okay, somebody's lost on A. Sorry. Okay, so part A. All right. So part A here, what we did, let me just make space here to just explain this again. So we have A, and our A, we're saying, so we see that our A says set of OX such that here the values of X, they've given us an interval. So this here can be written as an interval, meaning from 3 all the way up to what? 3 up to 12. But then it's not going to be a square bracket. So if you put a square bracket like this one here, it means that the numbers at the end, like 3, is going to be part of that interval. But we see there's just a less than here sign. So it's open here and it's open there. So it means that 3 and 12 are not part of that interval. So in a case where we had, for example, if we had 3 less than or equal to x, less than or equal to what? To 12. This would mean that 3 is part of the interval. Meaning if I'm going to start listing out my numbers, I'll start from 3. But 12 is not part of that interval. So I will not include what? 12. So that's what this equal sign means. So if it was here again, meaning I would now include what? 12 as part of that interval. So I would list from 3 going all the way up to 12. But in this case, in our case, we see that there is nothing of a sort. There's just less than there. So it means that we will start listing. So we are going 3. So 3 won't be part of there. So we'll start from 4. So 4, then we'll go 5, 6, and they're telling us it's natural numbers, the numbers we use for counting. That's 4, 5, 6, 7, then I have 8, 9, 10, then 11 here. 8, 9, 10, 11. Then 12 is not part of there. Then I'll just close like this. I don't know if that is clear. Okay, somebody says even C, they are lost. Okay, so on C, okay, let me go back to C. Okay, we get why C can be a bit confusing. I hope the A part was clear. Let me do C again. Let's do C again. So C. So C is given by this set here. So C is given by the set. So it says C is a set of OX such that, and it's been given by an equation, a linear equation that is 4 plus X equal to 3. And they're telling us that X is a member of the natural numbers. So natural numbers, we've said in this interval here, this interval, that's from 1 to infinity. So if you start counting 1, 2, 3, all the way up to infinity, going all the way, those are natural numbers. So now, I check my equation that this has been given by. So it's 4 plus x equal to 3. Then I can let x be the subject. So the additive inverse of 4 is negative 4. So I have 3 minus 4. Then this here just gives me negative 1. So now I check for the value that I found. Is it going to satisfy this part here where I have x a member of the natural numbers? So I ask, is negative 1 a natural number? So negative 1 is not a natural number because we said they will start from 1 going this way. So negative 1 is not a member of the natural numbers. So which means if negative 1 is not a member of the natural numbers, and the only thing I got here, so here, negative 1 is not part of that natural numbers. Okay, so yeah, negative 1 is not part of the natural numbers. And because it's not part of the natural numbers, meaning I will have to what? I will have to, it won't be part of that set since negative 1 is not a natural number. So if -1 is not in that set, and that's the only value that I got, it means that this set has to be what? Has to be empty, meaning it won't have any element since -1 is not a natural number. So, meaning C is just going to be equal to the empty set. So the empty set, you can write it like this, or as I said, another symbol you can use to denote the empty set is just phi, like this. This is called phi. Yeah, so that's what you can use there. I don't know if it's clear now. Okay, so somebody says they are lost on how we start with, it's clear now. Okay, thank you. So how they start with 4. So how we start with 4. So check your interval. Okay, let's go back a bit again to question 1. So as I said, if the meeting cuts, just rejoin. Yes, just rejoin. Uh, so we have this interval here. They're telling us starts from 3, x going to 12. This here is what we've been given. So this can be written in an interval form like this. So which means, and now they've told us that our x is a natural number. So what are the natural numbers that are in between here? And we see because we have open brackets here, meaning 3 and 4 are not there. So in a normal case, natural numbers will start counting from 1, 2, 3, 4, 5, 6, all the way like that. But then they've given us that we are starting, it's this interval, they're in between here. And 3 and 12 are not part. So 3 and 12 will not be part of this interval. But the rest of the numbers in between are going to be part of this interval. So meaning I will start listing from what? From 4. Because after 3 comes what? Comes 4. Then I'll list everything all the way up to the number just before 12, that is 11. Like that. That's why we're listing it that way. I hope it's clear now. Okay, okay. So, okay. Okay, thank you. So, it says it's clear. All right, so let's move on now to the next one. Uh, the next one, we have this here. And this question says, let R be the universal set. Rewrite each interval in set beta notation. So, R be the universal set. So we're dealing with what the universal set being R. So then they're telling us to write this in set beta notation. So we have the set A here. So where there's this, remember the square bracket means if we're going to write the less than or equal to symbol, I mean the square bracket means that when we write the symbol, this symbol here, meaning that the number, this 5 is part of the interval. So we start, this will be, set A is a set of OX, so say set of OX such that, so what are the values that X is taking up? So X is taking up from -5, and 5 is part of this interval because there's a square bracket there. So less than or equal to, then of course X is here, then less than 3. Since 3 here, we see it's open at 3, meaning that 3 is not part of that interval. Then we're saying this X has to be a member of the natural numbers because they've given us that our universal set is what? Natural numbers. So this here is going to be the set A. Okay. Yeah. Is there anybody who's confused on how we've gotten that there? Are we all clear on how we've managed to get this here? Okay, so nobody has typed that they are lost, so I guess everybody's up to pace. So with B, you do the same. So with B, you're going to just say B is set of OX such that, so it's open on both sides. So I'll start from 4 and it's going X up to 7 there. And of course, X is a member of the natural numbers like this. Okay. Uh, Okay, somebody's confused. Yes, where are you confused? Okay, the one who's just typed, I am confused, sir. I do not understand. Yeah, you can just unmute yourself and speak and tell me where exactly. Okay, the person is quiet. All right. So I don't know where you're confused, so that's gonna be hard to explain. So uh, the first question, okay, say the first question. All right. So let's see where is this. Let's start over again here. So the set A. So what you must know about an interval form. So they've given you first of all, they've said let R be the universal set. So the universal set in interval form, the universal set uh, R, of course, is from negative infinity to infinity. This is how it is. And since infinity is not a fixed point, so we can't say that we put square brackets. So every time you use these square brackets like this, let's say there's one here and there's a hint there. Whenever you use this square bracket, it means this one or the number this side to your left, or it can be to your right, is part of that interval that you're describing. It's part of the numbers that you're describing. If you use an open, if it's open like this, it's open here and it's open the other side or on either side, it means that they are not part of this interval. What is part is what is inside here, or the numbers in between there are the ones part. But 2 and 10, for example, in this case, is not part of that interval itself. Okay, so for one, I think with that now we can actually do it. So they're telling us we have one there, and so that's gonna be okay. So they're telling us it's from 5. So circular notation, we say x such that then this would mean I'm moving from negative 5. And negative 5, there's a square bracket there, so it's gonna be less than or equal to, meaning negative 5 is part of my interval, and then less than what? 3. And of course, they've told me that let R be the universal set, meaning that where I'm getting my X is from the what? The universal set. Universal set. That's why it comes there like that. Okay. Then for B, as I said, you do the same, R such that. So it's open on both sides. So it will be 4 less than X less than 7 and X a member of the natural numbers like that. Then I have C. So for C, so you can also always start like this, where you state that X is a member of the natural numbers because they've told you that's a universal set. Then you just write what remains there. So in this case, it's 0, comma 4. So meaning 0 and 4 are part of the interval like that. Then you can close it like that. With D, you do the same. You can always start with X, a member of the natural or a member of the real numbers. Then 2, so 2 there, it's open at 2, meaning 2 is not part of the interval. So it will just be a less than. Then 4 will have a less than or equal to. Therefore, like this. So this here is how you solve those questions there. So I have less than a minute left. So this video cut, then just open another the same link to start again. Okay. So hmm,